Okay, is there any one of these that you need to go through? Okay, which part, Shini? 8, part 1, 2 or 3? Part 2, okay, part 2. Find the total cost in dollars of the books. So this person buys 3 books at X dollars, then he buys N books at $20, and then 4 books at 2X each. The total cost in dollars. Okay, so let's start with the first one. 3 books at X dollars. How much is he going to spend on these 3 books? Shini? If he buys 3 books at X dollars each, how much is he spending on these 3 books? Yeah, correct. He spends 3x, and you got 3x by 3 multiplied by x, right? Then let's move on to the next set. N books at $20 each. So according to what she said, just multiply 20n. Now finally, we've got another set. 4 books at $2 each. What should we do with this 4 and 2x? Okay, we multiply them. So 4 times 2x. So 3x and 20n, they are unlike terms, so we cannot group them together. Here we have 8x. So we have a total of 3x plus 8x. They are like terms because they're all x terms. So we get a total of 11x plus 20n. So that is the amount that she spends. Okay? So once we have the total amount that she spends, we divide it by the total number, which is your answer in part A, to find the average cost of a book. Okay, question 3. Substitution question. Just make sure you substitute in correctly and you key in the values in your calculator accurately. So 75 and -6. Anybody got something other than 75? Have, right? I'm sure there is somebody. So what was the mistake? Let me guess. Your answer was -75? Zheng Jie, what's your answer? What did you say? 225. Who you get 225? For calculation. Anybody got -75? Ah, yes. Okay, so how did that happen? Because when you do part A, 3t squared, when you do the substitution, you should be writing this, -5, and you square it. Versus 3, okay, so wait, versus 3 times -5 squared. Do you see that both of these kind of look the same, but they are not exactly the same? So the question is there a difference? If you key the left one into our calculator, exactly as it is with the brackets, 3 bracket, -5, then you close bracket, you square it, we get 75. Versus, over here, on the right hand side, 3, you open the bracket, put a -5, you square it, you close the bracket, you get -75. So we see that both of these, they look quite similar, but our answers are different. One of it is correct, the other is wrong. So what is wrong over here? How do we end up with different answers in the first place? What is the issue over here? So you need to ask yourself, what exactly does -5 square mean? -5 square. It is given by -5 multiplied by -5. Right? So we have a negative times a negative, which gives us positive. Whereas in this case, when you have -5 squared, this actually means -5 multiplied by 5. This square over here belongs to the 5. Okay? Whereas this square over here belongs to negative 5. That is the difference. So here we end up with a negative times a positive to give us a negative answer. And so when you take a negative 25 multiplied by 3, you will get a negative 75. And that is why this is not the correct way to do it. Now another issue is that you may be able to know that this is the correct working, but when you key into your calculator, you either don't key in the brackets properly or you don't put a square at the correct position. And then you may end up with the wrong answer again. So you have to be very careful for this type of substitution questions. Next, for part B, it will be more straightforward over here, negative 6. Anybody needs help? Okay, then let's move on. Okay, again, substitution. 16 and 7.62. Anybody needs help? If you do, raise our hand, don't be shy. Okay, which part? Part B. Okay, so let's take a look at square root 2. Then there's a A, right? I'm going to substitute in a value of A. I put in the blank brackets first, then minus another bracket. So now I'm going to fill in the blanks. Notice that when I wrote this, I didn't refer to the values yet. When I see the letter to be substituted, I just put in brackets. And this is quite safe because if some of these numbers are negative, then you will not be forgetting to include the negative. If they are positive, no harm done. They remain as positive. Okay, so let's substitute A. A has a value of 3. Put it inside. C has a value of negative 4. So over here, this shows you why the brackets can be useful to you. Okay? So next, 2 times 3 power 3 minus negative 4. You can key everything into your calculator straight away. But just for practice, let's do it mentally. 3 power 3, what do we have? 27 times 2? 27 times 2? 54. Okay. Now what is the next sign? What shall I write next? Plus or minus? Plus. Because negative times negative gives us a positive. Okay, so plus 4. So here we have square root of 58. Root 58, 7.615. They wanted 3SF, right? So we must give more than 3SF. Maybe 7.615. Okay, let's give 5SF first. Only then can we round it off. Okay, so recap. To find the 3SF value, we need to first identify the first SF. So the first SF will be 7. Second, third, then you look at the fourth SF, which is a 5. So since this is a 5, we have to increase the 1 by 1. And we get 7.62. Ishan, okay? Where was your mistake? Okay. Now question 5. Simplify. 3a power 3 over 50c power 5. You have to get every part of it correct. Can I have a show of hands who got this correct? Okay, thank you, put on hands. So I think there's a need to go through this. So to simplify, we have a fraction divided by a fraction. What did your primary school teacher teach you? Fraction divided by fraction. Change what? Flip the what? Change the what, flip the what? Oh, okay. So actually some of my other students taught me this. Oh, Mr. Wong, when you see this, right, you should remember this. Looks like KFC lah. So they tell me, oh, this stands for keep, change, flip. So you keep the first fraction, you change the sign, divide to become multiply, then you flip the next fraction. So that's one way for you to remember it. So let's do that. Keep, change and flip. A squared over 10c cubed. Okay, so we have a fraction multiplied by a fraction. Fraction times fraction, you take the numerator times numerator, denominator times denominator, right? Please don't confuse this with your addition and subtraction, where you need the denominators to be the same. So since we're just multiplying, let's combine everything. Multiply. So over here, we end up with, in the numerator, 3 times A times A times A. So we have 3A cubed in the numerator. In the denominator, work with the numbers first. 5 times 10. So we get 50. Then we left with C squared and C cubed. So C squared times C cubed. Actually this means C times C, that's our C squared. Then C times C times C. How many are there altogether? 5. So C power 5. So actually you see that we don't really need to expand everything out. There's a shortcut, right? What can we do to get a 5 straight away? Okay, you add 2 plus 3. C power 5. So 3A cubed over 50 C power 5. Question 6, expansion. Anybody needs me to go through part 1, part A? Part B? Okay, part B. What was the difference between part A and part B? Besides there being 3 terms. I don't think the 3 terms is the problem. I think the problem might be this 2x. Instead of just one number, for example, like in part A, negative 3, then you just multiply negative 3 to 4x, negative 3 to negative 5. Here we have 2x. Maybe that is the problem. Okay, so let's see how we can do this. So it is the same rainbow method. We draw arrows. We take the entire 2x multiplied by 3x first. Just like in part A, negative 3 multiplied by 4x. So in this case, 2x multiplied by 3x. It's okay if you cannot do it mentally straight away. Write it down like this. Later on we do the expansion again. Next we have 2x times negative 4y. So we end up with negative 2x and 4y. Finally 2x with positive z. So plus 2x times z. Okay, Samuel, help us with the first expansion. What do we have over here? 6x squared. Okay, so the number times the number first. 6x squared. Next, minus 2 times 4, minus 8xy, plus 2xz. Hey? No wonder you all have problems with this. The answer here is wrong. 6x squared minus 8xy plus 2xz. Okay? Okay, moving on, question 7a. 3x over 20. Anybody needs help? Okay, what do we have to do first? Fraction minus fraction. Denominator must be the same. What is the LCM? 5 and 4? 20, okay, so you can do that. Then they say hence. So, when you see the word hence, you definitely need to use the result from part A. You cannot do it anywhere else. Even if you get a correct answer, but with a different method, without using part A, you will lose marks. Okay, so we have to find out how is part A related to part B. So we see that this actually appeared over here. 2x over 5 minus x over 4. right? They appeared. So since this is equal to this, then this is equal to this. We do the replacement straight away. From part A, instead of writing 2x over 5 minus x over 4, we get 3x over 20 equals to x minus 1. This is to address this word hence. Then what do we do from here? I've got a fraction equals to a non-fraction. Would it be easier if it is a fraction equal to a fraction? Then you know you can do your multiply this way. That's one way, right? If it is a fraction. So we can change this to become a fraction over 1. Alternatively, I want to get rid of this fraction. What can I do to both sides? Times how much? 20. To get rid of the denominator. So you do the same for the other side so that they remain equal. So we have 3x. So here, x minus 1 times 20. Is this okay? Is this okay? Sean, okay? Is this okay? Over here, Yishuan says we multiply by 20 on both sides. So that's what I did. Who thinks it's okay? Raise your hand. Who thinks it's not okay? Raise your hand. Sean, what do you think? Not okay. Why not okay? Who's okay? Huh? Oh, he says that this 20 is just multiplied to -1 when it should be multiplied to including the x. So we have to put the brackets like this. Now I know that some of you are aware that this 20 is multiplied to x, it is multiplied to -1. But when you present, you get lazy and you don't write down these brackets over here. And then when you continue to work it out, you get 20x minus 20, and then you get the correct answer in the end. I will still deduct you marks because it is mathematically wrong. Presentation is important. You have to put a bracket before I will accept your final answer. Get it? Okay, so from here on, I'm sure you can do it already. Okay, now question 8, expand and simplify. Question, are you okay with this question? Do you get it correct? No. Okay, so let's go through this. But can you help us? How should we expand the first 3c and 2c minus 5? Is there something that I can draw to help myself? Can I do this? Okay, so the first thing we have will be 3c multiplied by 2c. Okay, what's next? You help me out with the next one. So we multiply the first term, then multiply by -5. Yes. So we have plus 3c multiplied by -5, and we continue. Okay, now this is a problem. Here we have -5. We need to multiply to 4c. So minus 5 times 4c. The next one will be the same -5 times 3. Minus 5 times 3. Okay? One way we can look at it is, when you remove the brackets with a negative sign, all the signs inside will change. From a positive 4c, it will become a negative something. From a positive 3, it will become a negative something as well. So expanding all this out, 6c squared minus 15c minus 20c minus 15. Then you group all the c terms together. 6c squared minus 35c minus 15. So you might have this kind of things, this kind of drawings. They are perfectly fine. And I think they help. Then the next one, question 9. Again, we have a fraction minus fraction, so must make sure they have the same denominator. Can I have a show of hands who got this correct? Okay, those who didn't get it correct, I'm going to guess that this is what you did. 3a plus 2 times 5 over 30 minus 3 times 6, a minus 2 over 30. So far this is correct. I just changed the denominators both to 30. So here, multiply by 5, both top and bottom. Second fraction, both top and bottom, multiply by 6. Okay, so very happy. Wow, the denominator is the same already. Then you start to expand. 3a times 5, 15a. 2 times 5 plus 10. Now here's where the problem is going to start. 3 times 6, 18. Right? 3 times 6 is... Yeah, correct. 3 times 6, 18. 18 times a. 18a. You see a negative sign? So you put minus 18a. Then, you carry on. Okay. To simplify, make things easier for you, I change this to 18. So 18, negative 18a. Then you go on. 18 times negative 2 is negative 36. So you put negative 36. Those who got it wrong, check your work. Do you have negative 36? That is the problem. What's wrong with it? What's wrong with negative 36? Correct, well, Mr. Wong say 18 times negative must be negative. What's the problem? What is the sign of 18? Is 18 positive or negative? Look closely, 18 over there. Is it positive or negative? It's not positive. It's negative. Where is the negative for the 18? It is over here. If you join these two fractions together, it is actually like this. Right? Minus 18. Then negative 18 times 2, you get negative 18a. Negative 18 times negative 2 gives us positive 36. And so from here we have negative 3a plus 46 over 30. And if you had used negative 36 over here, your answer would have been negative 3a minus 26 over 30. So this will be wrong. Okay, I believe some of you actually got this. Okay, so know your mistakes, and how to avoid them in future. This is a very common type of question. And we like to test you on this because we want to see whether you will make this particular mistake. We are actually looking out for this particular mistake when we set this question. And if you still keep making the same mistake, that means you're not learning. And here I am telling you that we will test you for this. Okay, next one, 10a, factorizing. Take out all the common factors. So instead of just 2, we also have x in both terms. In fact, we have x squared in both of them. So we factorize out 2x squared. And we are left with 2x minus 1. The next one, when you have to factorize 4 terms, there is a standard way to do it. You choose 2 terms that have common factors. If the setter is nice to you, just group them this way. These two will have common factors. So let's take a look at it. Do they have common factors? 8 and 15. Nothing in common, right? Bx, Ay. Oh, nothing in common. They're not kind to you this time. Let us group 8bx and 6by. Positive 6by, okay? I am including the positive 6by. Then the other pair must be negative 15ay minus 20ax. So you can group them yourself. If you like, you can rewrite it 8bx plus 6by minus 15ay minus 20ax. Okay, so now our first two, we pair them up, we write down whatever is common for both of them. So let's start with the number 8 and 6. What is the common factor? 2. Then I've got bx and by. What is another common factor? Arisha? What? Do you say A? B? Do you say B? Yeah, okay, correct, it is B. See, B exists in both of them. So 2B. So when 8bx divided by 2b, we're left with 4x. Next, 6by divided by 2b, we're left with 3y. That is for the first pair. Okay, now the next one, over here. Here's where you might find it a little bit more challenging because we've got negative signs. For negative sign, you can just factorize out the negative number if you want. Okay, so let's start. What is the common factor for the number? 15 and 20. Common factor will be 5, right? So if we factorize out 5, if you factorize out positive 5 over here, what will your result be? Positive or negative? Negative. Okay, so we think one step in advance. If you factorize out positive 5, you will end up with a negative 3ay in the bracket. Do you want a negative 3? No, right? Because I know that eventually it has to look like this. Since inside the bracket they're both positive, I want to factorize out negative 5 instead. Okay, so let us do that. Factorize out negative 5. So we know that in the first term, we'll be left with 3ay. Positive 3ay. Now, besides negative 5, is there another common factor? A, exactly. So after I factorize out negative 5a, I'm left with positive 3y. So as you're doing, keep looking back, checking your work, checking and checking. If I were to expand this out, it will be negative 15ay. Ah, yeah, correct. Okay. Then on the other side, we have positive 4x. Now, are you happy to see this? You should be happy to see this because we have common factors over here already. 4x plus 3y, 4x plus 3y. Got to see. So you can factorize them out again. Equals to 4x plus 3y. In the other bracket, we have 2b minus 5a. Now hold your fingers on a scale of 1 to 5, 5 being I fully understand, 1 being I don't understand. What is your level for this particular question? Raise up high, raise up high. It's crucial, this question. Confirm test you one. Okay, if you're holding a 3 and below, you need practice. Go and look back at our old videos. I've shown you how, including some of these practices over here, for example, to change 3x minus 4y to become 4 negative 3x plus 4y. Do you remember what we have to do to get to this side? Put the negative sign in front. We did some of these examples. For example, another one, negative 2x plus b. You want to change all the sign. to become 2x minus b. So again, we put a negative sign over here. So this is going to be useful for us in this type of factorizing questions. Sometimes you need to flip them around. Next, solve this equation, and we have x equals to negative 6. Anybody needs help? Sure? Okay. And the last page of our homework. Okay, first one, 73 degrees, 42 and 329 degrees. Do you think I will get the full marks like this? No, I'll get 0 marks. Why? Because no reasons. So what should the reasons look like? So even if you know all these, no reasons, no marks. Okay, so first one, part A, angle ADC. ADC. Okay, this is the angle that I need. So how should we find that? Oh, are you using isosceles triangle over here? Okay, so can you all do it in one step? Can? Okay, so what is the one step method? 180 minus 34 over 2. Right? So we get 73 degrees. Okay, so now I show working already, right? Will I get my full marks? No, I'm still not going to get my full marks. Why? No reason. What's the reason? So when I look at this working, a few things that come to my mind. Where do you get 180 from? Cannot pop out from nowhere, right? So you need an explanation where you get 180 from. Then, is there another number that magically appears out of nowhere? What is the number? The 2 over there. Where did it come from? I need a reason for that. Okay, so the first one, 180 degrees. Why? Yeah, because you can tell me, hey, all the angles in a triangle must add up to 180 degrees. That is where I get 180 degrees from. We say angle sum or triangle. This will address the 180 degrees. Now what about the 2 over there? The other reason. Do we just write isosceles triangle? No. We say base angles or isosceles triangle. So these are the 2 reasons for this answer. Do not remove any of these words. I am already writing down the bare minimum for you. For example, if you remove this word, this angle symbol over here, then you just say sum of triangle. Then I'm not going to give you the mark. It has to be angle sum of triangle. If you just tell me isosceles triangle, are you talking about the length to me? No, you're talking about the base angles. So these are all keywords. Okay, now for part B, angle BAP. BAP. Okay, this is the angle I want to find out. So 42 degrees. How do we get 42 degrees? What is it equal to? ABC. You can say ABC or ABD, up to you. They're the same angle. Okay, and what is the reason? Why is it that this angle has to be equal to 42? Some of you are really good at this already. Aloysius, what's the reason? Samuel, what is this alternate angles, parallel lines? What is this? There's a letter that is inside. What letter is that? Huh? No lah, I mean, you know, I keep writing these things for you all. Do they look familiar? Do they look familiar? Right, these angles. So which letter did Aloysius use for this? Z. Okay, so this one will be our alternate angles. Okay, now revision. And we think you better listen carefully because you're going to be help us with question 13 already. The first one over here, when you see this letter F, these two angles, A and B, they are equal. What is the reason? Corresponding angles, parallel lines. So you look at the format, it is always something angles, parallel lines, something angles, parallel lines. Now the next one over here, A and B, how are they related? Is it again A equals to B, like everything else? Do they look the same? Do they look like they have the same size? No, they don't. So you cannot be telling me A equals to B already. So what is the other possibility? What about 180 degrees? Straight line. Interior angles, A plus B is 180 degrees. Interior angles, parallel lines. Okay? Now question, why do they have to add up to be 180 degrees? Why must they be 180 degrees? When else do you hear of this 180 degrees from? Adjacent angles on a straight line. Are they related? To answer your question, you can look for Zheng Jie, because he's an expert at deriving everything already. Right, Zheng Jie? Oh, you spend so many hours with me also cannot do it. Yeah, you spend so many minutes with me, I'm sure you can do it. In fact, he actually tried to derive everything because I didn't want to give him the answer. Okay, so it can be done. So part C, reflex angle CAB. CAB. Now CAB looks like this. But what are they talking about? What is this reflex angle CAB? It is this particular angle. This big angle. So reflex angles are angles that are greater than 180 degrees. Obtuse angles, they are greater than 90 but less than 180. So these are what you need to know also. And the final one will be, we talked about obtuse, we talked about reflex. And the last one, acute. So you need to know the range for all of them. Less than 90, more than 90, less than 180, more than 180. So how do we find this big angle? I can see at least two ways to do it. And I think it's helpful if I write down whatever we found out earlier on. A, B, C, 73 degrees. Okay, so how will you all do this? 180 minus what? 180 minus 73 plus 42. Like this? 360 minus like this? A bracket this part? Like this? Why? So, question, where did 360 come from? Angles at a point. So he's saying that, oh, everything add up must be 360. Then he take away this whole chunk. So where did the 180 come from? This 180 degrees, right? Then he take away 73. Where the 73? Oh, this one? Okay, he took away this angle. Then what is plus 24? Plus 42. BAD doesn't look correct. Must minus another 34. So you get rid of this, you get rid of this, you get rid of this. I'm still left with this big chunk. Then you shouldn't plus 42, you should minus 42, isn't it? Alright? Now is this correct? Yeah. So this particular 73 came from here. It is 73 because alternate angles, parallel lines again. this 34 degrees is given to us. This 42 was found previously. So that's how we can do it. Okay? And we will get 329 degrees. Anybody any other methods? Besides taking 360 degrees minus all those stuff? Can we take, since we know that this is 73, and I know that this is 42, how about 180 minus 73 minus 34 minus 42? So can, right? Yeah, then you get 31. Then once you get the 31, then you plus 180 lor. Okay, once you get the 31, you take 360 minus that 31. Okay? So two different methods. Now next one. We think, can you help us with BFG? Angle BFG equals to angle FBA. Okay, reason. Alternate angles, parallel lines. Good. So this will be 55 degrees. So since you know it already, put it down in your diagram. Oh, sorry. Okay, so that's part A. Part B, angle EHI. Okay, we think, help us with EHI. Angle A, B, AB is not an angle. Huh? H. ABH. Okay, what is your reason? What is the reason? Okay, again, alternate angles, parallel lines. Oh, but now I need ABH, then I have an unknown angle over here. What are you going to do about that? (180 minus 45 minus 40), then he gets this answer. Is that a reasonable plan? Is that reasonable? So you take 180 minus 45 minus 40 to get 85. So after that, he takes 45 plus 85. Is that it? To get 140. So because alternate angles, then you get the same answer. Anybody got a better idea? More straightforward? So that will work, yes. But I can do it in one step. What is the one step? Nadira? Do you have any idea? Does it involve this? No. Then how? Don't know. Anybody? I gave you a clue already. Yes? 180 minus 40. But where you get 180 from? So you must tell me the reason. What is the reason for 180 minus 40? Wow. Actually, we can just say interior angles, parallel lines, right? Remember the letter C? See, these two are parallel. See here we have parallel lines. So this 40 and this one over here, which is what they want, EHI, they are interior angles. So interior angles will add up to be 180 degrees. So to simplify our work, EHI will be 180 minus CBE. When we say interior angles, parallel lines. So it'll be 180 minus 40, 140 degrees. which is the same as what we think suggested just now also. Okay, by finding this angle and then alternate angles. The next part C, GEH. GEH. Oh, I already found this angle, so this is 140. So the next one to find over here. Any suggestions? Corresponding. You mean using by searching for this shape over here? Can you see this shape with this as the angle? Can see? Let me highlight it out for you. Is this what you mean? Right, so this angle has to be the same as this angle. And we think already taught us how to find this angle, adjacent angles on a straight line. So let's start with angle GEH will be equal to angle FBE. So we say corresponding angles, parallel lines. Then we move on to say that FBE is actually equal to 180 minus away 55, and you take away 40 degrees. Then the reason, because the 180 cannot pop out from nowhere, so this is adjacent angles on a straight line. So we have 85 degrees. So this is 85. This is also 85. Okay, finally, GEB. GEB. This is the last angle we need to find. So many ways of doing it. What will you choose? 180 minus 85. Where did the 180 come from? Adjacent angles on a straight line. Or you can use interior angles, parallel lines also, right? But I think you would prefer adjacent angles on a straight line. It's more straightforward. So part D, GEB, 180 degrees minus this particular angle. So let's label it first, GEH. Reason, adjacent angles on a straight line. Okay, and then we have all the answers.